Calculating valence is crucial in chemistry and biology as it helps predict chemical reactions, understand molecular structure, and identify chemical properties. Valence also plays a critical role in determining blood group compatibility and is essential in medical applications such as organ transplantation.
First, you need to remember the atomic number, symbols of elements, and their respective groups and periods in the periodic table. Valence is the combining capacity of an atom or a group of atoms. It's essentially the number of electrons an atom needs to gain or lose to achieve a stable electron configuration. Here's a step-by-step method to calculate the valence of a chemical compound. Step 1. Identify the elements present. Break down the compound into its constituent elements. For example, in water, H2O, the elements are hydrogen, H, and oxygen, O. Step 2. Determine the valency of each element. Use the periodic table to find the group number of each element. For elements in groups 1 to 17, the group number typically corresponds to the number of valence electrons. For elements in group 18, noble gases, they have a valency of 0 as they have a stable electron configuration. For transition metals, their valency can vary, so you might need a. Apply the concept of cross-valency. Write the valencies of each element above the respective symbols. Cross the valencies to determine the subscripts of each element in the compound's formula. Simplify the subscripts if possible.
Here are some short points to calculate valence electrons. Steps to calculate valence electrons. 1. Determine the atomic number. Find the atomic number of the element from the periodic table. 2. Identify the group number. Note the group number of the element in the periodic table. 3. Valence electrons for main group elements. For main group elements, S and P blocks, the number of valence electrons is equal to the group number. 4. Valence electrons for transition metals. For transition metals, D block, the number of valence electrons is typically 2, for the S electrons, but can vary depending on the specific element. 5. Valence electrons for inner transition metals. For inner transition metals, F block, the number of valence electrons is typically 3, for the S and D electrons. Shortcut to determine valence electrons. For elements in group 1, alkali metals, the number of valence electrons is 1. For elements in group 2, alkaline earth metals, the number of valence electrons is 2. For elements in groups 13 to 18, P block, the number of valence electrons is equal to the group number minus 10. By following these steps and shortcuts, you can easily determine the number of valence electrons for an element.